Hello, I am Syed Haque Nabil, CTO Cybernetics Robot Limited and founder uh, CRUX, which is www.cruxpd.com. Uh, we have been making turbine-based open source ventilator since last month. After the COVID-19 situation, actually during the COVID-19 situation in Bangladesh, we tried to make some technology which could be beneficial for doctor and other people. Uh, and after making face shield, goggles, and other technology, of course, open source, I just thought what it would be nice if we make a open source turbine based ventilator. And that time, lots of people making ventilator, but 95%, maybe 90 or 95% of those ventilators are MV based. But as you know, the this is not MV based ventilator is not actually the right solution. Most of the professional ventilators are making are made using turbine or pressurized air, so that I had no prior experience regarding ventilator. So as I am a physics student, I was a physics student. I thought it would be nice if we just go through some research and find out how to make a ventilator. So what we had done firstly is we went to the ICU doctor. Those are the guys who actually know about ventilator. So that we went to the ICU doctors, especially Northeast Medical College, Syed, Bangladesh. Those guys are awesome. They helped us a lot, and they demonstrate us real ventilator. Then we had started our research, and then after some research, we did some engineering, and we made a prototype. But the problem was the parts we had used, most of the parts are not so much available, so that we uh, we did a different approach. Like I have been working on drone technology since 2014. So I have lots of experience regarding drone. I worked with Bangladesh Army and other forces. So we thought we should use drone parts for making ventilator. It sounds weird, but most of the technology that we use in drone are really helpful for making ventilator, like BLDC motor, pressure sensor, uh, etc, etc, so that we could manage those parts and can make ventilators. So now I will show our ventilators. Today actually, yeah, I managed to work with pressure support mode. Already volume continuous ventilation with volume cycle is working great. And now I completed the pressure support mode. So now no CMB or now CMB is available, but SIMB mode and access control mode not yet available. This is just a very rudimentary ventilator, but we are trying to make it to a proper ventilator. So let's see. So this is the very early prototype of our ventilator, CRUX Open Source Ventilator from Bangladesh. And we will make all the document, design, everything open source. So don't worry. So what inside this is just a balloon, not inside, outside. This is just a balloon. This act like a test lung, as I could not find any test line in our country right now in this situation, so we have been using this balloon. And other thing we have been using is this hot water bag. So this is the patient circuit, and this is the proximal air sensor. So this is basically a orifice tube that we have designed to measure air uh, uh, velocity actually, so that we can integrate over time and we'll find total volume that have been delivered. So these two line, when air flows through this, we find a pressure difference, and we convert this pressure difference to flow. So if when we find flow rate, then we can integrate and find total volume. So, and one of the advantage of this orifice tube is this is bidirectional. Although both direction is not same, but we can manage it. So this is bidirectional, and this is the pressure circuit, and this is the PIP bulb and one-way valve. This PIP bulb is from actually another ventilator, but we have actually designed and made a proper PIP bulb, but in for the time being I'm not using, because I actually moved from my one hometown to another, and I just using this one, but I will release everything in open source circuit. So what is inside? So this is very rudimentary and very simple. So this is the MPXB7002 differential pressure sensor. Another differential pressure sensor is here. This is for flow measuring, and this is for pressure sensing. So this is the BL motor, and this is the actually turbine. Whole turbine is designed by CRUX. Okay, and this is now 3D printed. We have designed impeller, this body, everything, and printed in 3D with 3D printer. This servo is actually acting as a pressure cutter. Okay, so this servo can release the pressure very quickly. Actually, in our final version I have planned to use solenoid, not the servo motor, and two solenoid for more pressure control. And one of the interesting thing is this PIP valve actually controlled by this air pressure. Okay, so when inspiratory line is open, that means the pressure is high, then it will close automatically, and when we release the pressure here, this PIP valve is open and maintain the PIP by using this air pressure. And this air pressure here, we have designed a very efficient PIP bulb which is not in here, but our PIP bulb is more efficient than this professional making PIP bulb. So okay, so this is the ESC, electron speed controller, for controlling this BLDC motor. In our another version we are not using this BLDC motor. We are actually we will use a more efficient but less expensive motor. Okay, so this is the control circuit. Here is the op amp for this differential pressure sensor, but I have planned to replace this differential pressure sensor because this output is very low and we need a op amp, and whole system creates some error. But we have managed the error because the CMRR of this op amp is good for this sensor, so we can reduce the error. And finally, in the code we are using exponential moving average method to eliminate the sensor noise. So in this here we are using just a simple Arduino Mega, and this is here is a Bluetooth module which was designed by our company CRUX, www.cruxpd.com, and we are uploading all the data from this ventilator to our PC wirelessly using just simple Bluetooth. So don't worry, I will actually release all the files. So don't worry, this is the bench power supply we have been using right now. So let's start the ventilator and see the graph. Okay, so as you can see, this is the pressure support mode of our ventilator, and it's maintaining the peak pressure is about 5 centimeter H2, and this is about 11 centimeter H2 pressure support, and the TI time, inspiratory time is 1.5 second. So this actually working pretty good. So as you can see here, okay, I'm gonna replace this balloon with the hot water bag. So I just replace the balloon with this hot water bag, and we also in our ventilator we have some alarm function which is not here right now. This is a very early prototype, but it will have alarm, SIMB mode, assist control mode, and other smart mode. So so you can see the orifice tube here. So okay, this is the video 1 of this prototype. So you can subscribe so that you can I can keep you updated about this ventilator, and hopefully this project will be very successful, and as it will be open source, you can make it, and most importantly you can learn lots of things. If you can make ventilator, you will be able to make other technologies like biped machine, PFPR device, lots of device application actually. So stay tuned and hope for the best, and stay safe.